All right, so taking a look at the questions from page 354, 1 and 3, we're going to look at writing a bunch of these logarithmic expressions and rewrite them so that you don't have a logarithm of a product or a quotient or a power. Any of those things we're not going to allow. Now, the questions aren't going to go in order because of how I've scanned them out of the textbook. So for those of you with OCD, this is going to bug you. So we're going to start with part A, log to base 2 of x times x to the minus 1. That would be a product that we have to deal with. So we'll rewrite that as a sum. Log to base 2 of x and log to base 2 of x minus 1. Okay, there's no more products, there's no more quotients, there's no more powers, so A would be done. Okay, so rewriting this, I see a product first, so I will write it log to base 2 of A plus log to base 2 of B squared. And then we take another step because I see a power in here, so we'll leave the first part alone, log to base 2 of A, but the second part is going to be 2 log to base 2 of B. That is our best answer here. We've gotten rid of that exponent. Okay, so looking at this, if we try it all in one step, I see a product and I see a y to the 1/2 power. So you'll have log to base 3 of x plus this square root means the 1/2 power, so the power comes out as a 1/2 log to base 3 of y. Looking at G, this whole thing, x squared plus 1 would be to the 1/3 power. So I would then take that 1/3 and write it as 1/3 log to base 5 of x squared plus 1. Okay, and so we've written it that way. And we look at our next one. We have log to base 10 of x cubed, y4, and z6. So we're going to write it as x with a plus and y4, and then we're going to subtract the z to the 6, but also at the same time I'm going to move the powers out. So I'm going to put log to base 10, sorry, I'm going to put 3 log to base 10 of x plus 4 log to base 10 of y minus 6 log to base 10 of z. Okay, so putting all of those together, doing some more of these. Here we have a quotient, so this would be log to base 5 of x, subtract log to base 5 of 2. Okay, so here that 17 is to the 1/4 power. And so you're going to write that as 1/4 log to base 6 of 17. Here you have a power first, so you would put 10 log to base 2 of xy. And then this you want to change, so I would write it as 10 log to base 2 of x plus log to base 2 of y. Okay, that's one way to write that. Combining all of this, I would say that you're going to get 2 log to base b of x, subtract log to base b of y, subtract 3 log to base b of z. And our last one, since we're on a roll, 2 log to base 10 of a, subtract 4 log to base 10 of b, and then subtract 1/2 because of the square root power, log to base 10 of c. So then that's working all the rules down. Let's take the rules and work them backwards and combine them to a single logarithm instead. So now in this one, we're going to rewrite everything as a single logarithm. So in the first one, they're all log to base 10, so they can indeed be combined. So we're going to have a 12 multiply by a 7, but that 7 is going to have a 1/2 power. And then we're going to divide by a 2. So if I'm combining all of those, you still have logarithm, log to base 10, and the logarithm you're taking, you're going to have 12 in the numerator times the square root of 7, and all divide by 2. So, and I guess you could then simplify that if you felt like it and call it 6 root 7. Seems to look like it would be the way to go with that. So log to base 10 of 6 root 7. Okay, so even if it's A's and B's, we want to combine them. They're all log to base 2, so you're going to start with a log base 2 of, you have A plus B, so that means it's A times B, and then you're subtracting, the 2 is going to go onto the C and become C squared, and the subtract means divide by C squared. All right, so combining our third one, we're going to run out of room, so we're going to move it down a bit. So here they're both log to base 5. So when you combine those, you're going to have log to base 5. What is it going to be? Well, the numerator is going to be x squared minus 1. And the denominator is going to be x minus 1. Why is there a denominator? Because there's a subtract here. You, of course, wouldn't leave it that way, because this looks like a difference of squares. So that's x plus 1 on x minus 1. And those terms cancel. So you'd be left with log to base 5 of x plus 1 if you simplify it. And why wouldn't you? Okay, so for D, we'll work that one out. The 4 is going to become x to the 4th. 1/3 is going to be cube root of that bracket. And there's no power on the other one. And the next thing you're going to have is the subtract means that this term will be in the denominator when you combine. And this term will be in the numerator because it's added, and the x will be there. So what you will have is all log to base 2, and in the numerator you've got x to the 4th power. In the numerator you have x minus 1, and in the denominator you have the cube root of x squared plus 1. All right? So if we look at what we've got with this next one, we're going to combine these first, and then I'm going to apply the power. Okay, so a little bit further. So I still have a 1/2 out front, and now I'm going to combine all of those together. So I have a log to base 5, and I have x times y squared, because this 2 goes on the y, and that 3 goes on the z, but it's a minus, so it's subtract z to the 3rd. Okay, now all of that is to the 1/2 power. 1/2 power means you take that in and put it on that bracket. So you're going to combine it as log to base 5, and you might as well take the square root of x y squared over z cubed. Right, our last one now to look at is with f. We'll slide it in down here. So they're all log to base a, so that's how you're going to combine them. Log to base a, and now you've got c as a power, so it's d to the c power, s to the r power, and then the plus means you're going to multiply those and divide by the other. So you have b up top. You're going to also have d to the c power, divide by, because it says subtract, s to the r. All right, so this has just been a way of getting used to and familiar with these logarithmic equations, looking at trying to solve them and getting those skills, because the next step after this, we're getting closer and closer to actually taking derivatives of these functions, and once you're taking derivatives, it unlocks all of the really fun calculus. So hope I'm going to give you some questions, other questions to try. Hope you've learned stuff here.